Solubility is the quantity of a particular substance that can dissolve in a particular solvent. One of the three factors of solubility is temperature.
As the temperature increases, the solubility of a gas decreases. More gas is present in a solution with a lower temperature compared to a solution with a higher temperature. The reason for this gas solubility relationship with temperature is very similar to the reason that vapor pressure increases with temperature.
Increased temperature causes an increase in kinetic energy. The higher kinetic energy causes more motion in molecules, which break intermolecular bonds and escape from solution. This gas solubility relationship can be seen if you think about what happens to a soda as it stands around for a while at room temperature. That the taste is very flat since more of the carbon dioxide bubbles have escaped.
The solubility of a given solute in a given solvent typically depends on temperature. For many solids dissolved in liquid water, the solubility increases with temperature up to 100 degrees Celsius. In liquid water at high temperatures, the solubility of ionic solutes tends to decrease from the change of properties and structure of liquid water.
All of these factors can be seen through a solubility curve. A solubility curve is a graph showing the relationship between solubility and temperature. It shows the amount of solution that will dissolve at a certain temperature.
How to read a solubility curve. First, look at the title and legend of the graph to determine what types of solutes and solvents are used. Second, look at the x-axis to determine if the temperature is listed in Celsius or Fahrenheit. This is important if you are carrying out experiments that involve solubility. Third, look at the y-axis to determine the solvent type and quantity used to dissolve the solute. For example, the y-axis may tell you that the graph shows how many grams of solute dissolve in 100 grams of water at a given temperature. Fourth, look at the direction of the solubility curves. If a curve moves upward as the temperature increases, then the solute solubility also increases. If a curve moves downward as temperature increases, then the solute solubility decreases. Fifth, look at the names of the solutes on the graph. These will either be written next to the solubility curves or in a legend. Sixth, find the given temperature on the x-axis. For example, to determine how much sodium chloride dissolves in 100 grams of water at 37 degrees Celsius, look on the x-axis for the 37 degrees Celsius point. Seventh, it may be helpful to trace a vertical line from the point on the x-axis to the solubility curve of the solute. Eighth, trace a horizontal line from the intersection with the solubility curve to the y-axis. The value on the y-axis indicates the amount of solute that will dissolve in the solvent at a given temperature. To figure out if a solute will dissolve completely, first find the point on the y-axis for the amount of solute that will be added to a solvent. Next, find the point on the x-axis for the temperature of the solvent. Then, trace a horizontal line from the point on the y-axis and a vertical line from the point on the x-axis. Find where these two lines intersect. Compare the point of intersection to the solubility curve of the solvent. If the point is above the line, then the solute will not dissolve completely in the solvent at that temperature. If the point is below, then it will. The solubility curve shows the solubility of several compounds. The curves reveal the maximum amount of solute that can be dissolved in 100 grams of water over a range of temperatures.
For example, 22 grams of potassium chlorate, as shown as the brown line, will dissolve at 60 degrees Celsius. By looking at the x and y axis, it is very simple to understand how much of a solution will dissolve in a given temperature.
An increase in temperature results in a decrease of gas solubility in water.
A decrease in temperature results in an increase of gas solubility in water.
Temperature also affects solubility in solids.
Solubility in solids tends to increase with temperature up to 100 degrees Celsius.